This is the screencast for section 1.5, example 4. We're going to find an inverse function algebraically. Find an equation for this f to the negative 1 does not mean 1 over f. This actually symbolizes the inverse function of f of x if f of x equals x over x plus 1. So first of all, I'm going to call f of x y because it's just easier to write y than it is f of x, and they mean the same thing. I said that when you take an inverse, everything with x and y switch. So I need to exchange every x for every y. But I can't leave it like this. I have to solve for y. Well, there's two y's here, which can get very confusing. So first of all, let me get that one y out of the denominator. So now I've got xy plus x, I distributed, equals just y. Now if I get the y terms all on the same side of the equal sign, that's going to help. Because now I can factor out a y. So I get 1 minus x. So I factored a y from each term on the right side here, and now I can divide both sides by the 1 minus x and get that my new inverse function, or the inverse function of f of x, is x over 1 minus x. The now try problem number 15 also asks us to find the formula for the inverse of f. But in addition, it wants us to give us the domain, including any restrictions inherited from f. Okay, first things first. Let's exchange x and y. So first I'm going to write y equals 2x minus 3 over x plus 1, and I'm going to exchange every x for a y, and vice versa. Now, I got to get the y's out of the denominator. I'm going to distribute the x's, or the 1x, 2y minus 3. Now this time I want all the y's on one side of the equal sign again, but I want everything else on the other side. So I'm going to subtract 2y from both sides. I'm also going to subtract x from both sides. So in total I get xy minus 2y equals negative x minus 3. Now I can factor out a y from both terms on the left side of the equal sign, which leaves me with x minus 2. Divide both sides by that x minus 2. And I get y equals negative x minus 3 all over x minus 2. Okay, so give the domain of that inverse function, so I'm going to call that inverse of x, inverse f of x. Find the domain of that function and include any restrictions inherited from f. So the domain of the inverse function of f, just looking at the function, I can't make the denominator 0, so positive 2 has to be left out of the domain. So far, the domain of the inverse function of f is negative infinity to 2, and then 2 to infinity. Now I said before, everything associated with x and y switch, so the domain of the original function becomes the range of the inverse function, and the range of f will become the domain of the inverse function. So let's graph f and find out what the range of it was, so that we can determine if we were right on the domain for the inverse. So in f of x, in its own set of parentheses, I'm going to put the numerator 2x minus 3, and then I'm going to divide by parentheses x plus 1, so the denominator needs its own set of parentheses. Zoom 6. Now the range, I can see some sort of horizontal asymptote there that looks like it's about at positive 2. So since the range of f was negative infinity to 2 and 2 to infinity, I can be certain then that the domain of my inverse function is also the same.